Thanks so much for this opportunity to speak today. The title of the paper I'm presenting is How Gamification Affects Software Developers, Cautionary Evidence from a Natural Experiment on GitHub. This is an ICSI paper published in last year's ICSI. The lead author, Lukas, this is work coming out of his bachelor thesis. Actually, he was going to present today, but it's a part of student life that some days you have exams, and those are kind of hard to get out of. So I'm taking over for him today. Our other co-author was Markus Strohmaier, who's now at the University of Mannheim, and I'm Johannes Wachs at the Vienna University of Economics and Business, also at the Complexity Science Hub Vienna. So let me get to it. So what we did is we studied the effects of gamification on software developers. That was our motivation. So the term gamification refers to elements on online platforms like badges, achievements, leaderboards, that are rewarding certain kinds of user behavior or user accomplishment. And platform designers often try to steer users to specific activities using gamification. I'm sure you've all seen some of these before in your own work or while you're writing software. On software engineering platforms, gamification is quite common. You might be familiar with GitHub's contribution calendar, badges on NPM repos, Stack Overflow reputation points and badges, and also these Atlassian badges. And these are just a few examples. Really, this is a kind of phenomenon that we believe is really permeated collaborative software development. And why do we see this? Not just because it seems like fun, but actually past work has shown quite convincing that gamification works in a narrow sense, in the sense that it does influence user behavior. For example, users go out of their way to get badges on Stack Overflow. This is a nice paper by Ashton Anderson from the web conference just over 10 years ago. Users chase personal best and round number goals in general. This is evidence from a paper also by Anderson and his colleague Green. This is the second plot I have in the bottom right corner here. This is using data from chess. So once you reach a round number ranking in your online chess account, you tend to quit and immediately log off. An interesting, if cute, finding. Badges are also used not just because they're fun to collect, but they seem to signal some kind of quality or trust. And users are increasingly evaluated by how many points and badges they have, even professionally. And so we're motivated to study this phenomenon and ask, are there downsides to this world of gamification? Does gamification lead us to overwork, perhaps to chase signals, or to even imitate one another? And we explore these issues by exploiting a design change on GitHub, the well-known platform. So I'm at a software engineering conference. I don't need to explain what GitHub is. So here's the experiment. Let me set it up for you. So prior to June 2016, GitHub activity calendars included two counters. These were two counters of user streaks. What are streaks? So basically the counter on the left is streaks, is the longest all-time streak of uninterrupted activity that this user has made. And the counter on the right is the current active streak. So this user has been making contributions to GitHub 4 days in a row, and he has an all-time longest streak over 100 days. So here's the experiment. GitHub removed these counters without warning from user profiles in June 2016. This was some internal GitHub decision. One day to the next, these counters just disappeared. The removal of the feature was a controversial topic, to say the least. Users had quite mixed feelings. One saying, let me quote, "I'm incredibly disappointed in GitHub making this decision. I use these counters to encourage me to write code every day as a hobby." This guy has 85 thumbs up on this comment, 31 hearts. Then there are some other ways to reflect on the change. Another person wrote, "With a streak of 640 days in a row, wouldn't you think it's time for a few days off?" And actually, the interesting here are the social feedback cues are actually 33 thumbs down. So for us researchers, why is this interesting? Well, this is what we call more in the social sciences a natural experiment. So this is an opportunity to compare the behavior of users across the design change to better understand the effects of gamification on software developers. So how do we generate data to study this question? Well, we generated a historical streak database using data from the GitH torrent dump or project. We did a lot of data cleaning and organizing. So we did things like geolocating developers because we needed to infer their time zones. We removed bots and users who had clearly edited commit histories or users who had clearly edited their commit histories retroactively. Of course, that's possible on Git in any Git system. The resulting data set has over 400,000 developers with over 290 million valid contributions in this narrow time window around the design change. And all of the data and code is available on GitHub. Follow this link or reach out to me if you'd like a link offline. All the replication materials are available. So let's get to the analyses. We asked ourselves first, were developers streaking because of the counters? This plot illustrates the daily share of users with an ongoing streak of at least 20, 60, or 100 days, or 200 days, respectively. Those are the three different colored lines. And even though active streaks drop during, say, holidays, the Christmas holidays, and major GitHub outages, we observe an especially sharp drop in streaking behavior after the design change highlighted in red, right at the middle of the plot in the middle of 2016. So even though active streaks, so many of the developers seem to abandon the streaks right around when the streak feature was removed. Here's another way to look at this. We illustrate the share of streaks which survived at least X days. That's on the X-axis. Each line represents a collection of streaks which started in the same week. The 10 blue lines represent streaks which started in the first 10 weeks of 2016. So while the counters were still around before the design change happened. And then the 10 red lines represent streaks which started 1 year later in the first 10 weeks of 2017. So after the design change took place. We see a clear separation of these of the groups of lines and lower survival rates in general for the red lines after the change. This suggests that really long streaks, and these are really long streaks, so getting up to 100 days, were much more rare following the design change. So let's dig a bit deeper. We also asked, did this streak feature affect the timing of contributions? And one way to look at this is to consider the the share of total developer activity on the weekends versus weekdays. So in order to maintain a long streak, of course, you have to work on the weekend or make contributions. Maybe this isn't your work, but it's still some kind of labor. Here we visualize the share of activity on weekends, week by week. After the streak counters were removed, we observe a small but statistically significant drop in the share of activity taking place on the weekend. Unfortunately, right now, I don't have time to get into detail of the statistical models, but in the paper, you can find a nice analysis using a regression discontinuity model that makes this a bit more robust. Another finding with respect to the patterns of contributions we observed is something I share in this plot. So this plot illustrates another interesting change. On the x-axis, we bin the user activity during long streaks into deciles. The y-axis represents the share of days in that decile where only one single contribution was made. We see a natural trend, both before and after the change. At the end of a long streak, single contribution days are more common. But this tendency was more pronounced before the counters were removed. And what do we infer from this? What does this plot mean? Well, it means that while the counters were present, users would often log in, make a single contribution, likely not as involved as they do on other days, just to keep their streaks alive. So the last thing I want to mention today, that the last of our results we want to mention is addressing the question, did developers chase the streaks of friends? What do we mean by this? Well, to investigate this hypothesis, we recreated the social networks of developers at different points in time. So here, each node in this network represents a developer. And developers can follow each other on GitHub, like they do on Twitter. And we keep edges between developers if they mutually follow each other. And at a given point in time, each developer has a streak statistic. We labeled each node with their personal all-time longest streak, and we asked, is this streaking number correlated to the network? So are friends of a user with high streak record likely to have high streak records themselves? So to simplify this, we call a user a streaker if his or her all-time longest streak before the design change was above a threshold of 8, 15, or 32 days. In the second column, we calculated a conditional probability. What is the chance a streaking user has a streaking friend? Well, we compare the observed probability that a streaker has a streaking neighbor against the null model. So in the null model, we randomly shuffle the streaking labels through the network. We average the probability of streaking friends across many instances of this null model, and we see that while streak counters were visible, streaking was highly correlated in the social network. Well, why might this be? We propose two possible reasons. The first one corresponds to a hypothesis of sorting or homophily. Streakers might be more likely to befriend other streakers. The second explanation is social influence. Seeing a friend streaking might inspire a user also to streak. And in general, it's known that in purely observational data, it's very hard or maybe even impossible to distinguish between these two driving factors, the sorting or homophily factor on the one hand and the social influence factor on the other. But given that we have this natural experiment, we can detect influence if the correlation drops after the change. So, does it? In fact, it does. We do the same thing a year after the change. We run the same analyses, and we observe that the streaking correlation crashes after the design change. And without having the counter, streaking is practically or only very weakly correlated in the network. This is very strong influence we argue for, this is very strong evidence we argue for the influence hypothesis, and that the counters were energizing people to compete with one another. If this led to more weekend work and single contribution days, we think that this is actually a quite negative outcome of gamification. Overall, this is suggesting that influence and imitation are playing a major role in how we interact with these gamified elements. In other words, I get a lot of points on Stack Overflow, I get a lot of badges in some system, and I am constantly looking at my friends and neighbors to see how many points they have. And this drives me to pursue these points, sometimes in a bad way. So let me wrap it up quickly. Gamified elements had a significant effect on behavior. We feel we've presented good evidence to claim this. The counters may also have encouraged counterproductive behavior. So for example, we saw that users made contributions for many days without a break, including weekends and holidays. And single contribution days were common towards the end of long streaks. This suggests that users were often just logging in and doing anything to keep their streak going. We also saw that users imitated the streaking behavior of their neighbors, showing the power of counters as a social signal. Perhaps the counter spread an unhealthy norm among developers. To sum up our findings, I would say that gamification is not in and of itself a good or bad thing, but should be deployed with care and thought, and that the use of gamification can steer the behavior of software developers in particular, that's what we were studying in this case, in unexpected and perhaps unwanted directions. Thanks very much for your attention. I'm looking forward to your questions. Here's a link to our paper, and this is the team.